Today, everyone. We were doing ठीक है, record हुआ. we were doing redox. ठीक है, which was I mean, still part of electrochemistry. We're doing redox. Reduction was a gain of electrons. I told you, and that was the definition. It was a gain of electrons, and that's it. There are other ways of finding whether reduction is happening, which is decrease in oxidation state, gain of H atoms, loss of oxygen atoms. ठीक है, that is also called reduction. Lekin if they ever ask you what is reduction, it means a gain of electrons. And oxidation is a loss of electrons by definition. So what we did last time was that whenever you gain electrons, you become more negative, right? So if the charge is decreasing, that means reduction is happening. You're going down, that means reduction is happening. You gain one electron, you become -1. You gain another electron, you become -2, and so on. And whenever you lose electrons, you become more positively charged. You become more and more positively charged so you keep on losing electrons. So if you go from +1 to +7, that means you're becoming more positively charged. So that means you're losing electrons, and you're losing 6 electrons. And if you go from +7 to -1, that means you're going down. That means you're gaining electrons. The easy way to remember this is reduction means reducing. So if the charge is reducing, so that was जरार बस ये है कि वो electrons gain हो रहे ना, so that's reduction. ठीक है, that you gain electrons, that means reduction. You lose electrons, that means oxidation. Is that clear? अच्छा, so बस ठीक है, that was the only thing that we did. So क्या हुआ है? अच्छा, so I'm just going to do this, repeat this one more time. Al plus 3. What happens if it turns into Al? So that is reduction. The electrons are being gained. ठीक है, is that clear? So the electrons are being gained. You're gaining electrons. The charge is reducing. This is reduction happening. You're going from +3 to 0. So that's going down. That's reduction. Similarly, if you have, let's say, Mg plus 1 and it becomes Mg plus 2. So in this case, the charge is increasing. That means you're losing electrons. That means you lost 1 electron. That's oxidation. Okay, so keep this in mind. Going down, charge going down, decreasing, that's reduction. Going up, that's oxidation. Is that clear to everyone?
Sir, 1 minute, let me hold it.
अच्छा, so ये मैं भेजता हूँ एंड में. अच्छा, so it's going to be it's not a big subtopic. It's a very small topic. ठीक है, gaining electrons, losing electrons. Now, the important thing is how do you figure out the oxidation state? ठीक है, oxidation state is the charge. Sometimes they're going to tell you what the charge is. ठीक है, it's not really the charge, लेकिन you can at this point in iGCSE and O levels, you can think of it as the charge. So oxidation state. How do you calculate oxidation states? Well, there are ways of finding what the oxidation state of different compounds is. There's certain rules. For some, you already know. For example, group 1 in a compound, you know it's +1. If something is in group 2, well, you mostly know that it is going to be +2. If something is in group 3, you know it's going to be +3, right? When it forms compounds. Then you have oxygen, and it is mostly it's -2, but there are some exceptions. So except in H2O2. it is -1. And then there is hydrogen. So it's +1 with nonmetals. So it's losing electrons with nonmetals. And it's actually -1 with metals. When it comes to metals, metals are the ones that are losing electrons. And the hydrogen has to then gain electrons. I say anyway, so these are some of the common oxidation states or charges. For the rest, you're not really sure. Cl, well, it's mostly -1, but there are going to be a lot of cases where Cl is not always -1. Okay, so remember, we're studying a very simplified version of chemistry at the moment. So the charges that you're always sure about, it's these ones. It's oxygen. In almost 99.99% of the compounds, oxygen is -2. We're pretty sure about hydrogen. In almost 99.99% of the compounds with nonmetals, hydrogen is always +1. Group 1 is always +1. Group 2 is always +2. Group 3 is always +3. But for the rest, there are too many exceptions that you can't be sure. Sulfur is in group 6. Well, it likes to be -2, but it's got other oxidation states as well. So you got to remember that these are the ones that you are really sure about. Okay? As a plus, oxygen and hydrogen are very helpful. Why? Because most of the compounds around you, they either have hydrogen or oxygen. Hydrogen is one of the most abundant elements in the universe. So hydrogen is present in almost all compounds. कोई भी उठा लो, water has hydrogen. They're either going to have hydrogen or they're going to have oxygen in them, because those are one of the most abundant things on this planet. But anyways, these are the things that we are sure of. Now, using these charges, you can figure out the charges of the other substances. For example, NaCl. Well, we know Na is +1 and we know Cl is -1. This one we're kind of pretty sure about. But the thing is, Na, we are 100% sure that it's +1, right? Cl, we have some doubt whether it's going to be -1. So I'm just trying to tell you that there's a way of finding the unknown oxidation states. Let's assume that we didn't know what Cl was. So I'm going to write it, I'm going to give it a charge of X. I'm assuming that I don't know what Cl is. Now, this entire molecule is a neutral molecule. That means overall charge is 0. So the rule is that the individual charges on the elements, they all add up. They all are supposed to add up, and they should be equal to the overall charge, whatever the overall charge on the entire compound is. So Na is +1. So I'm going to apply this rule. I'm going to try and find out what Cl is. Na is +1. Cl, I don't know what the charge is. I'm going to give it X. But the entire molecule, NaCl, the entire compound, is neutral. It's 0 charge, right? So if I solve for X, X will come out to be equal to -1. That means Cl had a charge of -1, which we already knew. Okay, so I'm just telling you the method that if you know the charges of some of the elements or the oxidation states, you can figure out the oxidation states of the other ones. अच्छा sorry, ये गलत मैंने लिखा है. Dabira, Hania, thank you, thanks for pointing this out. Del up, कौन है Del वैसे? Hania?
Yes.
अच्छा ठीक है. Sorry, this is H2O2, not H2O. ठीक है, I wrote that incorrectly. This is hydrogen peroxide. ठीक है, वो मैंने गलत लिखा था. ठीक है. In water, oxygen is -2 in all compounds, except for one, which is H2O2. But anyways, is this part clear that if you don't know, so for example, I'm going to do another one. And अच्छा वो -1 मतलब वो क्रिस क्रॉस में भी यही बनता है ना, मैंने फेस इज +1 एंड O इज -1, राइट? तो उनका रेशो क्या होगा? इट्स गोना बी 1:1, राइट? Shadda, is that clear? Balki, Shadda, keep it simple. I'm not going to go into details about H2O2 because that is beyond the scope of your syllabus. You just need to know that H2O2 is -1. वो मतलब वो फिर extra वो फिर बहुत डिटेल में चले जाएंगे, which is not required at your end. ठीक है? As coming back to this, as let's say I have another molecule which is Na2SO4. Now, based on the ones that we are sure of, Na is group 1, so I know that it is +1. Okay, so Na, I'm sure it's +1. Sulfur, I have no idea what it is. So I'm going to take it as X. I don't know what sulfur is. Oxygen, I'm pretty confident that it's -2, right? And the overall molecule, the compound is neutral. So that means all the individual charges must add up to be equal to 0. Na is +1, but there are 2 of them. So I'm going to multiply it by 2. Sulfur, there's only 1. And then oxygen is -2, but there are 4 of them, right? So I'm going to multiply it by 4. So all the individual charges, they must add up to be equal to 0. So it's going to be 2 plus X minus 8, and that should be equal to 0. And if I solve for X, it's going to come out to be plus X. So over here, I've learned that sulfur is actually +6. ठीक है, ये बात clear है? Fatma, Fabia, Zarar, is this clear? Okay, we were sure of sodium, we were sure of oxygen. We have no idea what sulfur is, right? So we're going to do this for the other ones. Let's say CpO4. So I'm quite sure about H. I know it's +1. Well, it's mostly +1. There are 3 of them, so that's +1 times 3, right? Or +1, +1, +1, right? 3 H's. Phosphorus, I have no idea what phosphorus is. So I'm not sure what 100% sure. I'm going to write it as X. Oxygen, I'm quite sure that it is -2. And there are 4 oxygens, right? And this molecule is also neutral. So all of them, they must add up to be equal to, they must all add up to be equal to 0. So add up all of them, right? So what is it? It's going to be 3 plus X and -8, and that's going to give me 0. If you solve this, it's going to be, X would come out to be +5, which means phosphorus over here is +5. Okay. So this is how you keep, so we'll do more questions. So let's do another one. Okay, NO3 -1. Now over here, there's a difference because now the entire compound has a charge. It's an ion. It's an ion which has a charge. And Taha, don't confuse it with that. What you learned earlier was, for example, what you learned was that group 1 is +1, group 2 is +2, group 3 is +3, and group 7 is -1, group 6 is -2, and group 7 is group 7 is -1, group 6 is -2, and group 5 is -3, right? That is usually the case. But chemistry is a lot more complicated. So the thing is that what you learned, there's nothing wrong with that. Most compounds, N is going to be -3, S is going to be -2, group 7 is going to be -1. But they tend to lose or gain electrons. I mean, the way they bond, it's slightly more complicated. So this one, the thing that we are studying right now, that usually applies to those complicated molecules. For example, H3PO4 in front of you. You never learned how to draw the Dorian cross diagram of H3PO4 or NO3 minus 1. So for complicated molecules, what you learned earlier in chemical bonding, you wouldn't be sure about some elements. You'll be 100% sure about these charges. You'll be 100% sure about these. But for the other ones, you're not always quite sure. So for that, if you want to figure out what the oxidation state, I say you don't use the word valency. Make sure you never use the word valency. Valency is not really a scientific term, and it's a very confusing word. It means a lot of things in a lot of different scenarios. So make sure you never use the word valency when you're writing answers to your exams. It's either going to be the charge or you're going to use the word oxidation state. Don't use the word valency. Okay. So Taha, is this clear that these ones are like really complicated molecules? And you don't have to go into details about how did this ended up bonding with each other, because no one is going to ask you that. They won't even ask you about H3PO4 in A levels as well. But for these molecules, you should know, or you should, I mean, you know this, so you can kind of figure out what the charge is of the unknown one. So I'm going to do it for nitrate now. So N, I'm not sure what N is. So I'm going to take that as X. Oxygen, I'm sure of, it's a -2. And there are 3 of them, right? Now, this time, the charges must add up. And the overall charge now is not 0, it's -1, it's an ion, right? So we solve for that. So kya hai? What do we get? It's going to be X, and it's going to be -6, and equals -1, and X will come out to be equal to +5. So that means N over here is +5. ठीक है, is this clear? ये clear है? Okay, so that's what redox reactions are. Sorry, that's how you calculate the missing oxidation states. Now, how are you going to use that? Let me open a worksheet just 1 second. Electrochemistry. Yeah. Let me open a worksheet and keep this in mind. In a reaction, where's the thing? If the charge is going down, that means the substance is gaining electrons. If it's going up, that means it's losing electrons. It's getting oxidized. Keep that in mind. So I'm going to do first. I'm going to do a simple reaction where you don't have to calculate the charge. So, for example, you've got zinc reacting with, let's say, Ag +1, and it becomes Zn +2, and it becomes Ag. Now, this is a simple reaction because there's no need to actually find the oxidation state because I wrote down the charges. So what are the charges? Zinc has no charge, so that's, I mean, when nothing is written, that means it's 0 charge. This is also 0. Now, what's going to happen to the first one? What's going to happen to Ag +1? Is the charge going down or is it going up? +1 to that's reduction, right? If it reduces, if it decreases, that means it's reduction, and that means it's gains 1 electron, right? So what's happening to Zn? Charge going up or down? Yeah, well, increases or decreases? Well, it's up. Okay. So that means it's getting oxidized. That means it's so if it's going up, it oxidizes. That means it loses electrons. So that's the very first basic thing that they're going to ask you. What's happening to silver? Reduction is happening to silver. What's happening to zinc? Oxidation is happening to zinc. That's the first very basic thing that they're going to ask you. So we'll just practice that a bit more. Again, और questions एक second. So I have another one. I've got Cr 2+, and it's reacting with Sn, and that's 4+. And the product is Cr3+, and the other product is Sn2+. But if you can see the screen, what is happening to Cr? Up or down? Okay, what's happening to Cr? Oxidation or reduction? Anyone? Nabila, Fatma, Fabia, Shanze?
Through oxidation.
Okay, so this is oxidation. It's going up. And the other one is that it's going down, right? 4 to 2. So that means it decreases, it reduces, that's reduction. So that's gain of electrons, and this is loss of electrons. So that's the first thing that they're going to ask you. Now I'm going to do a more complicated case. The complicated case is that the charges will not be given to you. You would have to calculate the charges. So for example, the complicated case is that I've got IO3. So let's say this is my reaction. I've got IO3 -1 reacting with 5 N2O molecules. And it's also reacting with 2H + 1 ions. And the product is, एक second अपना. अच्छा, and the product is, किधर गया? Product ही गायब हो गया. I2 plus 10 molecules of NO, and there is H2O, right? So now the thing is, they didn't tell you what the charge is. For example, for each one, you would have to figure out what the oxidation state is to begin with. And so we're going to start with IO3 -1. Well, I know what I is. I know that's क्या था I? That's -2. I don't know what I know what O is. I don't know what I is. I is going to be taken as X. There are 3 oxygens, so it's going to be -2 times 3. And the total charge on the entire thing is -1. So if I solve for this, it's going to be -1 and +6, right? So it's going to give me +5. So that means my iodine over here is +5. Okay? And oxygen is -2. So I'm going to write that as well. Oxygen is -2. Together, IO3, that's -1. Okay, you clear? Is this clear that I found the individual oxidation states? Is that clear?
Yes, sir.
Okay, next one, N2O, right? So I need to figure out what N2O is. I don't know what N is, basically. So N is X. I don't know what it is. And there are 2 of them. So that's 2X. O I know is -2. And overall, the molecule is neutral. So if I solve for this, it's going to be 2X is equal to 2, and that's going to be 2 divided by 2, and that's going to give me +1. So that means my N is +1, and the oxygen is -2. H is +1, they already wrote that, so I don't have to solve for that. Iodine is neutral, though. That means when something is neutral, that's 0, right? You don't write a charge, it's obviously 0. Then I have 10 molecules of NO. For NO, I need to calculate again. It's N is X. O is what? It's -2. And again, it's a neutral molecule, so they should add up to be equal to 0. So it's going to be.
So we'll do nothing with the ratios. Like 10
Yeah,
NO है तो 10 into N नहीं होगा, 10x नहीं होगा.
अच्छा वो बताता हूँ. नहीं, I don't care how many N's there are. I'm just going to pick one molecule. I don't care whether there are 10 molecules of NO or not. I'm just interested in what is the charge or the oxidation state of that N in that compound. Bus. Whether there are 10 of them, I don't care at the moment. Is this clear? Similarly, N2O,
Yes.
you're just going to find it for N2O. Whether there are 5 molecules of N2O, we don't care. In N2O, the N is +1. Okay. In IO3 -1, the I has an oxidation state of +5. Okay. And H and O, we already know H in compounds is +1 and O is -2. So now this is slightly lengthier in the sense that you first have to do the whole math thing and you have to calculate and figure out what the oxidation states are. And once you do that, then you have to figure out who's getting reduced, who's getting oxidized. So बताओ okay, who got oxidized and who got reduced? Reduced who got reduced over here? क्या हुआ? ये बात ज़ैनब हानिया क्या हुआ? Who got reduced?
I.
Yeah, I got reduced. I was +5 and then I became 0. So the charge is decreasing. That is reduction. That is a gain of electrons, and it's specifically a gain of 5 electrons. I went from +5 all the way to 0. And who got oxidized?
N.
Okay, N got oxidized, went from +1 to 2 + 2. So charge increase, that means lost exactly 1 electron, right? So it got oxidized. Okay? Is this clear?
Yes.
So I'll do another one. The next one is what's the next one? So I've got CiO4 -1 plus pH3, and it's forming what? It's forming 3I -1 plus 2P4 plus 12 H2Os. अच्छा बताओ कि what's IO4 -1? What's I? सारे जरा कैलकुलेट करो मैं तो. What is I? Oxygen जो है, that's -2.
Seven plus 1.
ठीक है, they should all add up to be equal to -1. So +7. +7 है ना, right? Is that clear? अच्छा pH3, what is P? Unknown, right? H is 1, that's +1 times 3, right? And it's a neutral molecule, so they should all add up to be equal to 0, right? So X will come out to be -3, right? And H is +1. I is -1, they already told us. P is neutral at the moment, so that's 0. H we know is +1 and O is -2. We already know that. TK, is this clear, this equation, this reaction? Clear? Can you clear? Is that clear? Nabila, Shanze? मतलब ये clear है बात? अब बताओ कि
Yes, sir.
who's getting reduced, who's getting oxidized?
R is getting reduced and P is getting oxidized.
So I went from +7 down to -1, so reduced, right? And specifically gained how many electrons? +7 to -1, that's 8 electrons, right? And P went up. P went from -3 to 0. So it got oxidized. It means it lost electrons, right? So lost how many electrons? Lost 3. -3 to 0. It's going up. So is this 100% clear what's going on? Clear है
Yes,
सारों
sir.
को? I said now one last thing about redox reactions. And not exactly one last thing, or bhi hoga. Achha, but one thing is the naming of things. Substances that get reduced. The substances that get reduced, they would be called the oxidizing agent. They would be called the oxidizing agent, or sometimes they'll also be called the oxidant. क्या spelling? Oxidant. I don't know how to pronounce it. Oxidant. ठीक है? ये सही है. As the substances that get reduced, they're known as the oxidizing agent. So whoever got reduced, I'm going to write a small O dot A. The naming is opposite. The substance that's getting reduced, that's called the oxidizing agent. And the reason it's the opposite is because this is the agent who oxidizes pH3. Well, if this agent wasn't there, pH3 would not be getting oxidized, right? So it's called the oxidizing agent because it's oxidizing the other substance, right? And the substance that got oxidized, that's known as the reducing agent or the reductant, right? So make sure you know this. So whoever got reduced, that's your oxidizing agent. Whoever got oxidized, that's called your reducing agent. Chromium got oxidized, so that must be the reducing agent. Tin got reduced, so that must be the oxidizing agent. It's pretty simple, straightforward. Reduction happening, that's the oxidizing agent. Oxidation happening, then that substance is the reducing agent. ठीक है, clear है? Clear है कि नहीं clear?
Yes, sir. Clear.
So substances that
Yes, sir.
get oxidized, they would be called your reducing agent, or also known as the reductant, right? So so we're out of time, almost out of time, but what you need to know is there's some examples of powerful, I mean, that's the last thing, examples of powerful reducing agents. Actually, there's, okay, some examples of powerful reducing agents. Remember, there's one which is called potassium iodide. So if they ever ask, you don't have to go into details. If they ever ask you to name a reducing agent or a powerful reducing agent. So one of them is potassium iodide. That's Ki, K plus 1, I minus 1. That's number one. And there's another one which is sulfur dioxide. So make sure you know that these are two powerful reducing agents. And similarly, you need to know some examples of very powerful oxidizing agents. So number One is KMnO4, that's known as potassium permanganate or potassium manganate 7. And when it reacts, it is purple in color and it turns into colorless. And the second one is K2. That's potassium dichromate 6. It's a difficult name, you just have to remember the name. And when it reacts, it's orange color. And after reaction, it will turn to green. So you just have to memorize these four. If they ever ask you to write the name of a powerful oxidizing agent, it's just going to be potassium manganate 7 or potassium dichromate 6. Or if they ask you about reducing agents, you're going to write potassium iodide or sulfur dioxide. Okay. There's one last thing that we'll talk about. I'm just going to write it down. The oxidation and reduction related to metals and non-metals. Who gains electrons, who loses electrons. And we'll link it with the periodic table. So we'll talk about who wants to gain electrons, who wants to lose electrons, who wants to gain electron a lot, who wants to lose electrons a lot. So we'll talk about that tomorrow, okay? And we'll start doing past paper questions related to electrochemistry, okay? चलिए ठीक है, clear है?
Please share the notes.
मैं कर रहा हूँ, ठीक है?
Yeah, officer.
Okay, take care. हाफिज.